Hey there, educator, and welcome back to the Make Math Happen podcast. I'm your host, Lanisha, and just a quick reminder in our last episode, we focused on negative numbers, distance, and value. We talked about how the number line is not new to students, it's true to students, and how movement and direction and why understanding integers as positions and changes is far more powerful than simply memorizing rules. Today, though, we're going to stay right there on that number line, but we're going to widen the lens. The struggles that students have with fractions and decimals are not that different from the struggles they have with integers. The challenge is students don't understand the number or its relationship to other numbers. So again, it's connected. The same is true with fractions and the decimals. And those struggles show up today, they show up tomorrow, and they show up much later. And they end up creating hurdles for students that maybe wouldn't have been there had we done something a little different. And we're going to talk about what that little different could be today. I've seen some of these struggles and these challenges clearly in the students that I support. Many of them didn't relate fractions to division. They couldn't confidently place fractions on a number line. They were less proficient with decimals, how to read them, compare them, or even connect them back to fractions. And I support middle school students. So I want that to kind of sink into your spirit. If students are having difficulty with fractions on the number line and then with decimals after having been exposed to these concepts in elementary school, now we're teaching the middle school standards on top of the elementary school standards. And that can be really challenging for middle school teachers. And when we think about what it is that we want students to be able to do by the time they leave middle school, right? By eighth grade, we're talking about so many different concepts that built or have built on to all of the other previous years. The lack of understanding in fractions and decimals, again, it's going to show up everywhere. It's going to show up in equations. It's going to show up in exponent work. It's going to show up in proportional reasoning. So what I want us to do today is I want us to talk about fractions, decimals, and think about them in terms of representations of quantities. And when we're working with them, operating with them, it should be about those representations versus memorizing a trick. So let's dig into fractions first. One of the biggest disconnects students experience is not realizing that a fraction is division. When students see a fraction like 1/4, many of them don't see a quantity. They see a symbol, something to simplify maybe something to convert or something to operate on, or maybe they just see something and they're waiting for their teacher to tell them what it is. But a fraction is a relationship. It tells us how a whole has been partitioned and how many parts we're considering. This understanding begins early. In the elementary grade, students are partitioning shapes, they're folding paper, they're sharing collections, and they're talking about equal parts. They're reasoning about fair shares and wholes long before formal fraction notation appears. If those experiences are rushed, though, or if they are reduced to naming parts only, students miss the opportunity for that deeper learning and for them to build meaning. By the time students reach middle school, fractions shouldn't feel abstract. But unfortunately, for many students, they do. To be quite honest, for many adults, fractions still feel abstract. Now, the number line is one of the most powerful tools for helping students connect fractions and decimals and whole numbers. On the number line, fractions are not separate from decimals, right? They both occupy space, they both have a location, they have a distance from zero, and in some instances, the fraction is equivalent to the decimal, right? And we dig into that work deeper in eighth grade, but there's a benchmark place that we can kind of start with some of this work. But before we get into that, when students cannot place 1/4 or 3/4 on a number line, it's a signal that they don't yet understand the fraction as a quantity. And I think some of that might be our inconsistency in language. Have you ever been in the midst of a lesson and one moment you refer to it as 1/4 and the next moment you refer to it as a quarter, or one moment you refer to it as 3/4 and the next moment you refer to it as 3/4? We are assuming in that moment that students are following, that students understand that those two descriptions are the same. They're describing the same value. And in some cases, the students don't know that, right? If we don't have some type of visual, if we're not showing them quarters, then the students may not relate it, right? So they're not even understanding what it is that we are talking about. So what I'm positing today is that we can make shifts in our instruction, and those shifts can make a big difference. Along with asking students to place values on a number line, we need to also ask them, what do you visualize when you see this number? What do you see? What comes up in your mind when I say 1/4? Is it a shaded region? Is it a partition rectangle? Is it even a partition circle? Is it a point between 0 and 1? That's where that number line comes in. And I'm seeing a lot of middle school students who don't understand that location on the number line, that relationship between those numbers along that number line. If students aren't visualizing anything, this is important information for us to have as the teacher, right? Because seeing is believing, and seeing opens the door to understanding. We don't want to be saying things in class and students aren't visualizing anything. This doesn't mean that we want them daydreaming, but what we do want them to do is create a picture in their mind of what it is that we're talking about so that when we have the conversation, they can reference it. When we have the conversation, they're grounded in their understanding, right? In what they see in their mind's eye. The number line gives us a powerful way to show equivalence. When I taught estimating irrational numbers, I had students create a number line with the integers on the bottom and their perfect squares on the top. Now, the thing about the perfect squares on the top, obviously, the radical was there, right? So I had 0 on the bottom, I had the square root of 0 on the top. The goal here was to show that those values were equivalent representations, just written differently. I wanted them to be able to use that number line to place those irrational values in between them. And it was really challenging because students were not consistently writing the radicals. So then they had 2 on the bottom and 4 on the top. Well, those are not the same, right? Those are not in the same location on the number line. Me walking around and monitoring what students were doing and putting in their notebook allowed me to see that students were discarding that symbol. And so I had to correct it. And it was a good thing that I was doing that, right? Otherwise, them minimizing the importance of the radical could have been something that was permanent in their mind. And then when it became time for them to do work later on, it would have been very challenging for them to answer questions because now they're like, well, wait a minute, what is this 4 and this 2 mean? Why are they stacked on top of each other? We did a lot of work with squares, creating squares, literal squares, and then working backwards and having the area of a square and finding that area's side length, square rooting. We did a lot of work with that. So when we got to the point where we were creating the number line, again, I wanted students to see the equivalence, to know that when I multiply 2 times 2, that I am getting that perfect square. And then when I move backwards, right, when I move backwards and I square root 4, I'm going to get 2. And as I say this on the podcast, I have another idea. I'll share that later. But the same idea of creating that number line so that students can see the equivalent between these representations of values, it applies here when we're talking about those fractions. Teachers can place benchmark fractions on the bottom and they can place the decimal on the top. Right? We can stack them vertically so that students know that we're talking about equivalence here. And so, for example, we might have 1/2 on the bottom. We might have 5/10 or 0.5 on the top. We might have 1/4 on the bottom, and we would have 25 hundredths or 0.25 on the top. 3/4 on the bottom and 75 hundredths on the top or 0.75. Seeing those values aligned helps students make sense of more and less. It helps them compare without guessing. It grounds equivalence in space instead of memory. So, and I want to hit on this memory thing because obviously we want students to remember. We want them to be able to recall, but recall is really, it's a very low level on our depth of knowledge, right? On our Bloom's taxonomy. What we really want them to do is to be able to see it in space and make sense of it so that they can apply it in different ways. That's really what we want them to do. Remembering is a part of that. But unfortunately, if we focus only on memorizing, right, just giving them a set of isolated facts for them to commit to memory, because it doesn't make sense, it's going to be hard for them to retain that information. It's going to be hard for them to apply that information in different ways. It's going to be hard for them to be efficient. And I'm going to give you an example of where this shows up. I want you to think about, if you're my age, I'm 41. If you're close to my age, I want you to think about some of the things that you learned in school. And I want you to think about solving problems and whether or not you're able to do them in different ways, right? To think about if you ever look at a number and you consider the composition of that number in the strategy that you choose to use to work with that number. If you don't, then chances are you probably memorize something versus really understanding the connections of the numbers that are in the situation. right? If you're pigeonholed, like if you only do long division, if you only stack your numbers to multiply them, right? If you define area as length times width, if you define perimeter as add up all the sides, then you were memorizing a set of rules, not what the things meant, not their connections to other things. And so in that case, sometimes you're not going to be as efficient to solve new problems with new context presented in different ways because you aren't flexible. I mean, that's just the reality of the situation. So again, when we think about space, when we think about the number line, when we think about the relationship between the values and showing that relationship on the number line, that's geometry quietly doing the work, right? Because that's that spatial reasoning, the placement, the alignment, the distance. All of it matters. Okay. And I want us to think again about the decimals and how they're about place value, not point moving. Decimals are another area where language often works against understanding. Students are frequently told to move the decimal, but the decimal doesn't move. The digits do. And more importantly, the value changes, right? If I multiply 1 by 10, I'm not moving a decimal point. I'm placing the digit 1 into a position that is 10 times greater. That means it shifts one place to the left. When I say it, I'm talking about the digit, not the decimal, because each place represents a unit that is 10 times the one before it. And if we're moving to the right, we're talking about the place value being a tenth of the one to the left. So it's important that students understand the relationship between the place value because it makes it easier. When students focus only on moving the decimal, they lose all sense of magnitude. They're not even thinking about the size of the number anymore. They're just focusing on moving the decimal. They can't even read the number to you. They can't tell you what the number is. They can't relate that number to other things. All they can tell you is, we just moved the decimal. Well, why? Why? The other day, I was having a conversation with students and we were multiplying 1 and 8 tenths times 1 and 8 tenths, right? It was 1 and 8 tenths squared or 1.8 squared. And so I asked them after we finished multiplying, how do you know that it should be 2 decimal places? Students were like, because there's 2 places after the decimal. I said, I want us to dig a little bit deeper. What is that place value that the 8 is in? Somebody said the tenths place. And I said, okay, so let's think about 1/10. If I multiply 1/10 by 1/10, what's my product? They said 100ths. Exactly. So again, tell me, why do we have 2 decimal places? Oh, right? Students have the ability to understand it. We just have to give them the opportunity to understand it. Okay, so decimals, like fractions, live on the number line. They describe refined partitions of space. When students understand place value spatially, multiplying and dividing powers of 10 become intuitive instead of procedural. They're not just shouting out, move the decimal. They're able to make sense of, oh, wait, you said 200 times 10? Yeah, 2000. We're not having to take that time to actually move that decimal. Okay. And this is something, I'm going to be honest with you. This is something that I still struggle with. Like, it's so ingrained in my head sometimes about moving that decimal. I force myself to, let's not think about that. Let's think about this in a different way. I challenge my thinking all the time because I'm trying to break free of feeling like I need to follow a set procedure to do things. I want to be flexible myself, which takes me to my next point about why flexible representation matters. One of the goals of understanding math is helping students become flexible thinkers. Students should be able to move between fractions and decimals based on what makes the most sense in the moment. But many students aren't flexible. Many adults aren't flexible. And often it's because we're not looking at those quantities. When students see 1/4, I want them to envision a tape diagram showing a rectangle split into 4 equal parts with one of them shaded. And if they don't see that, then I would like for them to see a circle, or I want them to see some shape that is related to what I just described. I want them to also see a 100 grid with 25 squares shaded, representing 25 out of 100. Those representations describe the same quantity. Seeing makes understanding possible. Understanding makes retention more likely. Retention makes application attainable. Making thinking visible with math journals is something that I've been working on a lot lately. And there's been so much back and forth about interactive notebooks and writing things down and students exploring and taking time to write. And we could do this during the synthesis. There's so much conversation around this. but I want us to consider just how powerful note taking could be. Not in the sense of kids are just sitting down and they're just writing their little hearts away. I know that note taking isn't always common in early grades, but after students explore a concept, there's real value in having them record their thinking. And I'm not talking about just early grades, I'm talking about period across all grade levels. And again, listen to what I said after they've explored a concept, because I know during the exploration, it's going to be messy, right? They could even have a journal just for messily figuring things out, but then they need to have a dedicated math journal that is organized, that they can look at and make sense of. Because after learning what fractions mean, I want students to be able to visualize those diagrams, right? So again, if I'm in elementary school, we're working on learning about fractions, can I not add the diagrams that we work with to a math journal? After exploring number lines, can I not sketch what I discovered and label my reasoning? That way, the thinking doesn't disappear when the learning ends. It becomes referenceable. It also helps families. Imagine if you have a math journal in your class and you're allowing your students to take it home. When parents see diagrams, when they see the models, when they see the explanation in the notebook, they're better prepared to support homework and study sessions without having to rely on remembering what they learned because it was probably different. And now they're confusing the babies or they're giving the babies rules. And then I shared with you guys in the earlier podcast that whenever we teach a child something procedurally first, their brain almost shuts down to the relational instruction. So we don't want parents trying to teach them a rule if we ain't made it to the rule yet, right? Remember I told you guys when we talk about algorithms, that's kind of like the last step. So the only way that we can empower families to support what we're doing in the classroom is if we give them access to what we're doing in the classroom. We don't have the books like we used to have back in the day where they would have worked out problems. And I got to shout out Akil Parker here because he talked about this the other day where they have the examples of worked out information. We don't have those a lot. A lot of teachers that I'm talking to, they don't have a textbook. They might have a workbook, but those workbooks don't have worked out problems or really clear notes for students to reference. So we have to build that. We have to build that. And then you got to get students hype about building this. Guys, this is your math journal. You could take this from one grade level to the next. Imagine a student making it to 8th grade and they have their journals from 3rd grade, 4th grade, 5th grade, 6th grade, and 7th grade. And if there was something that they just needed to figure out, like, wait a minute, let me just flip back to my journal and see what I did. But I'm willing to bet you that if a child had a journal and they were working with that journal and their parent was supporting them in reviewing that journal and making sense of that journal, and the teacher was referencing that journal before they started new information, and they were making connections, that student wouldn't even need the journal. It would just be something on the bookshelf that they could pass down to siblings, or they could pass down to cousins, but they probably wouldn't even need it because it's all up here now. And I'm pointing to my head. It's all up here. They've committed it. They understand it. They've retained it. They're applying it. They're transferring it. And that's powerful, y'all. So classroom reality check. By 7th and 8th grade, students are expected to divide fractions. Actually, they're dividing fractions in 6th grade. They're operating with decimals and they're reasoning flexibly across representation. That's the goal. But if the meaning isn't there, students rely on tricks. They rely on things like keep, change, flip. They're saying things like move the decimal. And unfortunately, the tricks don't transfer because they end up applying them incorrectly. They don't know when to use them, when not to use them. They don't know how to reason about the response they got because they don't understand the values. This isn't a student problem. It's a pacing and representation problem. Everything that we do is connected, y'all. I've been hinting on geometry throughout this entire series, and we're on part 3 now. And we're talking about number systems, and I'm still talking about geometry. Everything is connected. Okay, so when you go back to work this week, before students compute with fractions or decimals, I want you to pause. I want you to have them to pause. I want you to give them a number line if you haven't already. I want you to ask them to place the values. Ask them what do they visualize when they see the number. Ask them which representation makes the most sense and why. Don't do any more shortcuts. No more tricks, y'all. Let's focus on the reasoning. I'm hearing so many people complaining about students not thinking, but if we're all complaining and nobody's changing the way they're asking questions, the way they allow students to explore, the way they allow students to make sense, then guess what? The next teacher after you is going to have the same complaint. Somebody somewhere is going to say, you know what? I might have this thought. I might be annoyed by this. I might be a little frustrated. But instead of me complaining, I'm going to change something. Then I'm going to tell my colleagues, y'all, let's change this together. Then I'm going to tell my hallway, let's change this together. Then before you know it, it is rampant all over your school. Everybody is saying we're going to take a stand and we're going to focus on training these kids to think. Yeah. So today's work prepares students for everything that follows. When students understand fractions as division and decimals as place value, ratios feel natural, algebra becomes less intimidating, equations make sense in context because students aren't just manipulating numbers, they understand the quantities those numbers represent. Next time, we'll close the month by talking about number sense that transfers and how this work positions students for ratios and algebraic thinking. It's the same story, y'all, just a deeper understanding. I'll talk to you soon.